In this lesson, we're going to configure some basic VXLAN. For the VXLAN configuration, we're going to leverage a lab environment where we're going to extend layer 2 between some top-of-rack switches. As you can see in this drawing, we have an environment with two spines here at the top, spine 1 and spine 2, and then four leafs, leaf 1, leaf 2, leaf 3, and leaf 4. Connected to leaf 1, we have host 1, and connected to leaf 3, we have host 2. I would call this VXLAN deployment an intra-data center use case of VXLAN. Looking at the drawing, we see a simple leaf spine network, and more specifically, we call this a layer 3 leaf spine deployment. For the layer 3 communication between the leaves and the spines, we're using BGP. You could also deploy the layer 3 leaf spine with OSPF or ISIS, intermediate system to intermediate system. In this topology, our VLANs, VLAN 12 and VLAN 34, are deployed for hosts connecting into our top-of-rack switches, which are leaf 1, leaf 2, leaf 3, and leaf 4. In this topology, leaf 1 and leaf 2 are acting as top-of-rack switches in an MLAG domain. The running MLAG, or multi-chassis link aggregation, is the method to provide physical redundancy and first hop redundancy to the servers that are connected to them. Leaf 3 and Leaf 4 are also in an MLAG domain, providing the same level of physical and first hop redundancy for the host to connect to them. Notice the VXLAN labeling we have in the drawing. The leaves are the only place that we're actually running VXLAN, and I have them labeled here as the VTEPs, or the VXLAN virtual tunnel endpoints. The spines are unaware of VXLAN. The spines simply route the packets they receive based on the information in the BGP routing table. We have jumbo frames enabled throughout this topology to accommodate the encapsulation that the VTEPs, our leaves, add to the packets that require VXLAN bridging. For this lab, we're going to provide layer 2 extension between leaf pairs 1 and 2 and 3 and 4 so that both VLAN 12 and VLAN 34 can be available in both racks. We'll focus our configuration walkthrough on leaf 1 and leaf 3. First, let's ping between leaf 1 and leaf 3 to ensure that we have layer 3 reachability from loopback to loopback. So on leaf 1, we'll be pinging 172.16.0.5, and then jumping over to leaf 3, we'll ping 172.16.0.3. We're pinging the loopbacks of these leaves because that is where our VXLAN interface is tied to, as you'll see when we configure the VTI, or the VXLAN interface. Let's check that our hosts can reach their default gateway. So we'll log into host 1, show IP interface brief. We see that host 1 has the address of 172.16.112.201, and his default gateway is simply the .1. So we'll ping 172.16.112.1, and then the same for host 2. Host 2's IP address is 172.16.112.202, and his default gateway is the same, .1. Ping 172.16.112.1. Both hosts can reach their local default gateway. And now let's take a look at the MAC address table of each of the switches. On leaf 1, show MAC address dash table, and we can see that we have one dynamically learned MAC address, that's our host 1, that ends in 4E73. And then over on leaf 3, we'll issue the same command, show MAC address dash table. And we can see he's also learned one MAC address dynamically, and that's the one that ends in 0CED. Now, can we ping from leaf 1 to host 1, which is directly connected to leaf 1? Ping 172.16.112.201. Yes, leaf 1 can ping the directly connected host, host 1. We just sent a ping from leaf 1 to host 1. And we'll do the same on leaf 3. But before we get there, from leaf 1, let's see if we can ping host 2. From leaf 1, we're going to attempt to ping host 2 to 112.202. And right away, we can see that our pings are failing. Because we haven't built the VXLAN yet, we verified without VXLAN or pre-VXLAN configuration, leaf 1 cannot ping the host connected to leaf 3. And let's repeat these same steps on leaf 3. Jump over to leaf 3. Let's ping the locally connected host, host 2, 172.16.112.202. And yes, leaf 3 can ping host 2, but then when we try to ping host 1, we'll see that this will fail. Again, because we haven't built VXLAN yet. Time to build some VXLAN. On leaf 1, we need to create the VXLAN interface, what's known as the VTI. We need to provide the source of the traffic, which is going to be loopback 0. We'll create the head-end replication flood list, and we'll associate VLAN 12 to a VNI. And in this lab, we'll use the VNI number of 10,012. So going over to leaf 1, config, enter, and then it's interface VXLAN 1, enter. And then here we can issue a question mark, see some of the options that are available in this interface configuration mode. We're going to do VXLAN source interface. We're going to source it from the interface loopback 0. Next, we'll create the flood list, VXLAN flood VTEP, and then the IP address of leaf 3, 172.16.0.5. Again, that flood list is so that we know where to send replicated broadcast, unknown unicast, and multicast traffic. And finally, we're going to configure the VLAN to VNI mapping. This is a one-to-one relationship. VXLAN, VLAN 12, and we're going to map that to VNI 10,012. And our verification, show run interface VXLAN 1. And we can see our source interface. It also provides the UDP port number that we're using, 4789, the VLAN to VNI mapping, and our VXLAN flood list for the head-end replication. Now we need to do the same thing over on leaf 3. Get out of configuration mode here, jump over to leaf 3, configure interface VXLAN 1, VXLAN source from loopback 0, and then our VXLAN flood list, VXLAN flood VTEP 172.16.0.3, which is the loopback address of leaf 1. And then finally, VXLAN VLAN 12 mapped to VNI 10,012. So that's VXLAN space VLAN space 12 space VNI space 10,012. And then our verification again, show run interface VXLAN 1. Now from leaf 1, let's try again to ping host 2. Jump on leaf 1, ping that local host first, ping 172.16.112.201. We can see we can reach our local host. And now let's try to ping host 2 that's on leaf 3. And there we go. We can now ping host 2 connected to leaf 3 from leaf 1. From leaf 3, we can repeat the same steps. Exit from here, jump over to leaf 3. Again, ping that localhost 172.16.112.202. We see we have local connectivity, and then also ping over to the host 1, that's hanging off of leaf 1. And now we can reach host 1 from leaf 3. For our final verification step, let's ping from host to host. Exit from here, log into host 1, show IP interface brief. We can see that host 1 is the 172.16.112.201. And to ping over to host 2, that's going to be ping 172.16.112.202. Enter. And we can see that host 1 can ping host 2. Just for good measure, we'll jump over to host 2, enable show IP interface brief. And we can see his address is 172.16.112.202. And we're going to ping over to host 1 at 201. Ping 172.16.112.201. Enter. And there we can see that host 2 can ping host 1. And there you go. We just added VXLAN bridging within our data center to extend VLAN 12 from the TORs of leaf 1 to leaf 3 so that hosts living in different racks have layer 2 adjacency despite being separated by a layer 3 leaf spine topology. Let's log into leaf 1, take a look at our tables now. So if we issue the show MAC address table command that we'd entered before, we still have our dynamically learned localhost of host 1, but now you can see that we also have dynamic MAC addresses that we've learned via VXLAN, as indicated by the VX1 under our ports as the next hop or the egress interface to use to reach those addresses. We can also look at a VXLAN address table with the command show VXLAN address-table. And here we can see our MAC addresses and the VXLAN and the specific VTEP IP address to use to reach that MAC address. And we can see the same thing over on leaf 3. Show MAC address-table. And we see our next hop is the VXLAN1 interface for some of our dynamically learned addresses, and then also the show VXLAN address-table command to see the IP address of the VTEPs used to reach these specific MAC addresses. As a technology, there's a lot of pre-deployment homework, including understanding VXLAN bridging, VXLAN routing, and verifying what your hardware can support. If in a mixed vendor environment, making sure that you understand how each vendor implements the flooding requirements to support our BUM traffic, that broadcast, unknown unicast, and multicast traffic. Be sure to read the Arista configuration guide, transfer of information documents, and visit EOS Central for articles that help explain the various deployment scenarios and supported features of VXLAN.